Good evening. Can you hear me? Daniel, Karen, Vega? Very good. I'm going to start the desktop sharing. And can you see the desktop okay? Very good. Welcome. Before we begin, are there any questions? Thank you, Daniel. Okay, just a reminder, team project must have the team leaders and what OS each team is doing by Sunday via email to me. I'm expecting that. We did chapter 10. Were there any questions on 10? Talking about RAID and the organization of large disks, that kind of thing. We'll discuss 11. Make a note that the homework questions, chapter 10 and 11, are due this Sunday, and confer question we'll answer tonight. I'm going to discuss the file organization used by DOS after we go through chapter 11. And I want to demonstrate HexDump because it's a tool I provide. It's something I wrote in VB, and I gave it to you guys. I'm just seeing where it is. Oh, here it is. It's in next week's resources. And there's two programs there. One is a Windows version, and the other is a command line version. And I'll share with you how that works if we have time. Otherwise, I guess I can do it next week. I do want to mention this. All the students have an opportunity to create the final exam. And I'll put a model discussion that describes how I want the questions answered. And you'll just reply with your questions to it. So you'll see that and you'll reply. I don't want you to create new discussions for this. I just want you to reply to my one model question, okay? My one model, you'll reply. That way I know that I'm going to take this off the replies numbers when I do the grading at the end. What this is for is so that you know all the questions that will be on the final, well, I would say 80% of them, and you know what the answer should be. Okay? The list is on Canvas, and it's this list right here, Chapter to Student Final Exam Questions. And I've got it here. So what it really means is this. Chapter 1, we'd have 2 people creating 3 questions each. Chapter 2, we would have 2 people creating 3 questions each. I don't know how this happens. This is interesting to me. It looks like it somehow messed up because these are 2 different people. So this had to be also a 2, would be my guess. I'm going to redo this. It didn't load right. I did it in Excel, and apparently when I copied it, it went kind of bad. So just wait on that. But the idea is that you're going to go to this, whatever chapter I assigned you, and you're going to create 3 multiple choice questions, very much like the multiple choice on my tests. Yeah, hi Kang. Yeah, to pick it up, I'm going to bring this up next week, so you don't have to worry about it this week. Yeah, I'll talk about it next week, since this is chapter week 8. I just thought I'd give you a heads up, so don't worry about it. And then to pick up the other stuff I talked about, you could review the first 5 or so minutes of the recording, okay? All right, what else are we going to talk about? Well, we might as well start discussion on chapter 11, the file system interface. It's a good chapter. We talk about the file concept, access methods, directory structures, mounting a file system, sharing, protection, that type of thing. I'll try to illustrate some of these things. Contiguous logical address space. It's similar ID. Yeah. Hang on. That better? Okay. What contiguous logical address space means, logically, when you look at a file, it's contiguous, but when it's on disk, it's not. It's in separate places. It's typically not contiguous. When we talk about, I think the last chapter is file allocation, we'll learn about where we stick files. But logically, they're contiguous. I don't like his breakout here. This is not my breakout, the way I think of file types. In my mind, there's 2 types: text files, binary. Okay? And data can be text or binary. Programs are almost always binary. So, you know, it's a nice type, but it's not one that I use. Okay, so my definition is binary text. And text files are human readable. Binary files are not human readable. And they could be data, numeric, it could be anything. They're binary. Does that make sense to you guys? Oh, image files are binary. Media files are binary. You can't open a media file and read it as text. You can't open an image file and read it as text. So text is human readable. In my 30+ years of programming, this is how I broke it up. So anything that's human readable, it's basically textual based, is a text file. Anything else is binary. Can't read it. Can't figure out what it's doing. Okay? Is that clear? Yeah, there is gray areas on this, and when we get to security, I'll show you a text file that is a text file. You can open it, you can see all the text characters, but you'd be hard-pressed to figure out what it says because it's encrypted. So I'll show you that when we talk about encryption. So, I mean, it's a little kind of gray area of my definition. Let's see, like this file, right? This file right here. It's a text file. It's human readable. And I've got examples of binary when we talk about text dump. I'll show you binary. Okay, that's the file concept. Okay, file structures can be of different types of structures. No structure, just a sequence of words or bytes. A simple record structure where you have lines that are either fixed length or variable length, or a complex structure. It's a formatted document like this PowerPoint. If you looked at this PowerPoint presentation, it's a complex data structure. A program has to be able to read it and interpret it. Same thing with Word, database, data. All of those are complex structures. Who decides what it is? Well, the operating system can decide of the type, or the program can decide the type, like the Word program. Yeah, just like process control block has attributes, files have attributes. And we'll talk more about this as to where this is located, this information about a file. It's got the name, an identifier, unique tag number that identifies the file within the system, the type needed for systems that support different types, location, pointer to a file location on the device, so some kind of a pointer. How big is it? What's its protection? Date, time, and user identification. And their information about the files are in some kind of directory structure. It was also maintained on the disk. So we're going to have to understand the structures as well as the files themselves. Okay, so a file is an abstract data type, meaning it's logical. And because it is logical, you have these abstract functions that you could do on a file. And then you would implement them in another layer. So this is the abstract layer. And then there's, of course, the physical layer of what really happens. So you kind of can think of these as the API layer. So you can create a file, you can write to it, you can read it, you can reposition within the file, you can delete the file, you could truncate the file, and then you can have a function called open file or close file. And we'll talk more about what open really does in your program and what happens. I'll try to illustrate the details of this at one point, because it's really interesting to look at. Okay, open files. Pieces of data are needed to manage open files. The file pointer, pointer to the last read or write location for process. Remember, threads have access to files. So all the threads in a program can share file pointers. File open count, counter of number of times a file is open. I guess you can allow removal of data from an open file table when the last closes it. So you have a count concept that the operating system would keep on that file. Disk location, cache, and access rights. With opening a file, you need a concept of accessing it to write, basically. So you have mandatory or advisory. Mandatory access denied depending on locks held and requested. Advisory would be process can find status of locks and decide what to do. So basically, if we set it up as a mandatory, then it's denied based on what kind of locks are being held and requested. typically, I think in most systems, if a program opens a file, and we're not talking about a database at this point, because database engines manage the locking and the sharing of record sets that are in its file system of structure. What we're really talking about is pre or non-database types of access, like this file that PowerPoint has open. If I try to modify this file somehow in another program, I would get this is locked. This PowerPoint presentation file that we've got opened in PowerPoint, it's locked by another resource. So you have this locking going on typically at the file management level. The database level is the engine that you're running is managing those files. Okay, so those files are typically locked by the database, but you could have multiple accesses to the database engine and it supplies the data back. Whereas programs typically want to open a file and lock it. And that's what most programs do. Occasionally you might open it shared, but you typically don't write to it if you do that. Okay, and there's an example of locking. I'm not going to go through this. Java is great. I really like Java. I taught that I think twice in my past career at the Enza there. When I was on site, I taught it. I think it's 35A. Is that right? 35A? Yes. Okay. Okay. The extensions mean things. Typically, and in Windows, they're really used, highly used in Windows. And the 4 executable extensions, do you know what they are in Windows? You know, that represent programs. There are 4 executable extensions. EXE, that's one. Good. Boy, that's an old one. Linn. .com. No. .bat. And I guess there's a 5th. I forgot about bin, but there's a 5th. And this goes way back. It's called a PIF file, Program Interface File. And it really is like a setup. It's like BAT. It's like a BAT concept. Yeah. That's it. Okay. Now, those extensions, I have DOS open here, a command prompt open. And let me run. So I'm going to go to my tools that I've got on the C drive, and I'm going to run hexdump.net, and I don't have to put the .exe. because it is assumed that it'll look it up and figure out it's executable. And it ran, and the first parameter must be the file name that you want to dump. Okay, so it did run, and it ran this one fine. I'll come back to this later. Do you know where all of these, like when you want to run a file, let's go and open up something. Let me right mouse click and open with, and it chooses what to open it with, but based on the extension of the file. And it could have others, and I could choose a different program. Do you know where these are kept in Windows? Oh, that's a good guess, but no, it's in the registry. Now, I'm going to lose you guys when I open the registry, so I should have done that before. So let me run regedit. I know I lost you guys. It wants to clear. Can you see it now? This is regedit. This is the registry program. I'm back. Is that correct? Thank you. Yeah. If you look under current user, let me think a second. Maybe under classes root. I think it's under classes root. Yeah. If you look, all of these are extensions, and they all have programs identified and information identified where they are, and that's how it's maintained in Windows. So if I went to BAT, I'm going to find BAT. Can't find BAT. That file, yeah. Yeah, and it takes us to a registry key, and if we chase down this registry key, we would see it would start the command interpreter or something of that nature. And then if you can install your own extensions, but there's a ton of them, as you can see through my system. Here's docx, and so docx is a Word document. All right, let's see what it starts. Word exe. It looks like it starts. Well, this is WordPad. I guess this would be one of the choices that you could open up. Is WordPad versus Word itself. And then there's also Word. Yeah, I got waylaid for just a second and I forgot to turn on talk. Thanks for letting me know. But you should hear me and see me okay now, right? Okay, very good. Oh, this is technology at its best. I mean, to me, this is remarkable technology compared to other things. Okay, I want to talk about access methods. And why I'm going to talk about it is because on the test, I have a complex question, which is a 5-pointer. And you're going to kind of want to know how to put the access methods with the allocation methods we're going to talk about next week for Chapter 12. Okay? So the sequential access is typically sequential, like read, write. A good example of sequential is this text file. This text file is a sequential file. It was read and written sequentially. PowerPoint, probably a little more complex, but it was also probably written sequentially. Then you have this concept of direct access, where you read some number, and that number is an offset somewhere in the file. Okay? Relative block number is N, the way he describes it. So you can also position to N and then read next, write next, rewrite. Okay? So direct access means you could go anywhere in that file and write or read. Whereas sequential access says if you want to insert a record somewhere, you have to rewrite that. And there's a problem, homework problem, that takes you through that. You know, like how many reads and writes do you have to use if you do sequential or indexed or direct? And that way you'll figure that out when you do that problem. It's a lot of fun. Okay, so sequential access. Good. Think of tape. Tape is a good sequential access type of medium. You can simulate sequential access on a direct access file. It's not very effective, but you can do it. Oh, this is a good example of index. When I first got my hands on Foxbase, it was, well, DBase. I guess it was DBase first. Ashton Tate was the maker, manufacturer, creator of DBase, and they did a fabulous job. That you could create a structure in DBase, and you also had the language, and you also had, this was in DOS, you also had the ability to write screen things, and of course it wasn't a graphical user interface, but it looked pretty close to being a nice interface on a simple system. But they had this concept where you had an index file and you had a key, so you would have a key to the file, and then as you were adding records, it would maintain the index in alphabetic sequence, and the pointer would point to an offset within the relative file. So this worked really well in DOS, and it was quick and efficient. But that's what an index is. An index is you have some mechanism with some kind of value, and where is that value located in the real file? Is that clear? Does anybody work with DBase or Foxbase at all? Yeah, I think Foxbase is now owned by Microsoft. I'm not sure. No, must be a database guy. I'm not sure about that anymore. I've been out of it too long. Although I still have my manuals and I still have the disks and all of that. Okay, let's talk about a directory structure. Usually you have some kind of a pointer to the files. So you'd have this directory structure with the name of the file that you really are looking for, and then a pointer to where it really is in the file system. So that's both the directory structure and the files are stored on the disk. Okay, we talked last time that disks could be subdivided into partitions, and we talked about the partitions can be RAID or RAW or formatted with a file system, and I showed you I formatted on DOS, I formatted a file system for you on Tuesday. Partitions are known as mini disks or slices. An entity containing a file system is usually a volume. And a volume can expand more than one physical disk. Okay, so each volume containing a file system tracks the file system's info on a device, or a volume table of contents, VTOC. On the mainframes, the VTOC was the entry and the location of all of the file's contents on the mainframe. Then there's general purpose file systems and special purpose file systems. A general purpose file system might be what? What example? Do you have any examples of what a special purpose file system might be? Anybody? Well, how is the data stored on your phone? So you guys got a phone, not a smartphone, just a regular phone. My guess is it's stored in a special purpose file system, not a general purpose. Okay. Typically, your smartphones have a little operating system under it that what they have, they might have some version of Linux, a small version of Linux under it. That would be a general purpose file system. At any rate, it could be a good example. I know my phone, I tie it into my computer and it can't really do anything with it. Okay, so now in your partition, you have a carved out area of your directory that has a pointer to all your files. Okay? And that's how most systems are. Typically the directory is in a certain high location or low location, depending on your file system. The other thing I wanted to say is some file systems like Unix, they have nodes throughout their file that is part of the directory structure. So it's not physically in one part of the disk, like in this example. So what kind of operations do you perform on a directory? Well, search for a file. Okay, so when I do dir, I'm getting a directory of everything that's in that particular location called C:\my tools. Let's see, if I wanted to do directory of all zip files, it would give me the directory of all zip files. And that's what search for a file would do. Create a file, there's commands for that, right? I could make mkdir, make directory. I could create a file. To create a file in DOS, it's a little bit different. You can't like use, I don't think truncate exists, but it exists in DOS. Yeah, it's not a recognized internal command. I think so. But I could do something like this. I suppose I could yeah, it didn't like that. I could do this though. Cat. Well, I have to think about it. Haven't used it in a while. To just simply create a file. You could do it through a program, or you could output something from a program to a file. Type it to a file. Delete a file, that is available. List a directory, rename a file, traverse the file system. Okay, typically those are commands that you would have in your system. Of course, you want to be able to locate a file quickly. So you could use a single level directory to find things, but it would certainly be a naming problem because these have to be unique names. So this method doesn't really work well. A little bit better is you have a user 1 which has this setup, and a user 2 which has this, and a user 3. So by user you could have different structures, and that's pretty efficient. And finally you get to tree structure directories, which we use today. First of all, they're easy to traverse. They're recursive. You could have a recursive program easily recursing itself to get to what you want to find. So it really lends itself very well. And there's a I wanted to go and show you this one. I don't know how long it's going to run. Let me do this. I don't want to do anything that has a lot of stuff. Well, users. Let's go to users. And let's run tree and create a file called C:\. Okay, it's working, and it's done. It took a bit, so let's change directory back to my tool, and it's 28,000 bytes, so I'm going to type it to more. See if I can find the pipe symbol. And this is what it looks like. So this is everything under that drive. User alien and all of my stuff. And I could fit these, and then you just go through it. And I used to save these. In other words, many years ago, I would, whenever I was backing up my system, I would also run tree and save the file and back that up. And it saved me one day, and I'll tell you that story some point. Now we can get rid of that file. And now we'll get rid of it, and it's gone. If it didn't, on the delete here, if it didn't find it, it would give me an error, file not found. Okay, so that's the tree structure. It's very efficient. You saw how fast it is in that program. It's pretty fast. It took about 5 seconds. The concept of absolute versus relative path, right? Relative path, this is my path that I'm currently in. And then if I went like that, or do this directory, and then go back a path, I didn't like that. Oh, because I didn't do it right. Problem is, sometimes I forget I'm in DOS rather than, and that's my C drive. So I went back relative to where I currently am. So I went 2 steps back. And you can do that. That's relative. Let's see. You can share subdirectories and files in this structure. So that's pretty cool. You could have links. Windows doesn't really support links, but Linux and Unix supports symbolic links. Yeah, you could have issues in your structure in this. You could have issues, so you got to really be careful when you're going down this graph of directories to make sure that you either find it or you don't. In the cases, you've got 2 unhexes here, right? You want to be on the right one. And then you're sharing these, Pretty complex. Okay. File system must be mounted before it can be accessed. You don't typically mount stuff in Windows. It mounts it for you. But the other file systems in Unix is where you would mount a file system. Let me see how much memory I have. Okay. I think. I want to start up Ubuntu. It's like it's off now. It means it's going to boot up. It's fun to watch it boot up. They kind of hid the stuff until it comes to the graphical interface. They used to be able to see all the services starting, and that was fun to watch. But I guess you could do that. I just didn't know where in this thing you can see that. Okay, we'll let it start up. Let's go back to the presentation. Okay. So the idea is if you have a different file system, you can mount it at a specific mount point that you'd want to put in your system. And now you can access it. And that's pretty cool. There's file sharing concepts. And we'll talk about protection in a little bit. But file sharing concepts is you want to be able to share files with other users. And how you do it is through some kind of protection. You could have a distributed system where the files are shared across the network. And one method is the network file system. It's pretty common to use NFS. It's just another layer. Okay, so you've got all these layers to get to your data and your file. Let's see. So if you're going to share, you would have some sort of user ID, and you'd have some sort of permission or protections per user, and group IDs that allow the users to be in groups or preventing group access rights. Okay, on remote file systems, you could manually, I don't know if any of you have ever used FTP, File Transfer Protocol. It's a protocol that's under TCP/IP. Have you guys used FTP? Yes. Okay, good. Let me log in. I'm glad it started up clean. Give me a message that it started it up clean. What it does is it periodically checks the file system. In this case, it hasn't been on for maybe a week or so. So it actually ran some sort of a check of this file system. Let me see if I can. Yeah, I can't really. I guess I can. I don't like scrolling. See, I don't like scrolling back and forth. But I want to be able to see you guys. So I guess this will be okay. I wanted to go here. It's running slow, and I don't know why it's running so slow on my system. It could be that it's just eating up my CPU. Let me check. No, it's not really eating up my CPU. And it's working. I don't know why we're not opening it. It's just running slow. And this is something I experience a lot of. This particular virtual machine, it's just running slow. You can see I've got opened quite a few windows. So if you were doing something like FTP, let me see. Oh, I don't know what the command is on this box. Let's see. There is FTP. might be that I have to install something. I thought it would come automatically with this box. I haven't done much on this box. I have another machine that I've done a lot more on. It just takes so long to do stuff here. I don't do it. But anyway, if you do want to find out stuff, you would do like what I did. Man of it, and then Q quits. The letter Q quits. Man is manual, and it's really pretty good functioning. So let's move this so we can close it. All right. Now I was going to try and run FTP for you. I wonder if I can run it here. Yeah, I can run it here in Windows. So you would in help gives you the commands. Like you can change directory and things of that nature. You can make a directory. But you would open a port. So you would open in some places you can't get to, right? So let me think. Let me open. See if it'll let me in. Well, I don't see a response. So my guess is it's not gonna let me in. Yeah, it's not gonna do anything. Yeah, not connected. Let me think a second. I was going to try and show you how that worked, but I guess it didn't be successful. Not many machines now, or not many sites allow you to FTP in. The Anza used to, so maybe I could do that for you. Let me think. What site was that? Let me see if I can find it and move the Anza list. It used to be Puma. Puma was the site that did FTP. I don't see any Puma. It must be quite a while ago. I don't see. Yeah, I don't see it. Anyway, you would know it because it would not say HTTP, it would say FTP. Okay, well, that wasn't successful. Client servers, network file systems, standard Unix client server protocol. This is good. The CIFS is a Windows protocol for cross, and oh god, in 2003 or 4, I had a small company, and we would do consulting, and I went and consulted at a small company that was trying to connect their Unix server to a Windows server using this protocol, but they were getting failures, and it took me about 2 days to debug what was happening. And it ended up being a security issue. Okay, file sharing failure modes, remote file systems. Same kind of concept. If some error occurs, it percolates that error up the chain. Okay, if you're going to have multiple users accessing a shared file simultaneously, you have to worry about consistency. Remember deadlocks in Chapter 7, synchronous algorithms? You're going to have to handle that same way, same issues. Only instead of it being a memory resource, it's a file resource. Protection. Read, write, execute, append, delete, list. And these are the typical kinds of accesses that can occur. So you need to have a mechanism that says each user can have read, write, or whatever to the file, that particular file or directory. Access lists and groups. Who's ever doing Linux or Unix will explain this more, but it's easy to see. If we come back here, boy, I leave it for a second and it wants to lock me up. Oh wow, look at that. Sorry, the Bluetooth 1710 has experienced an internal error. If you notice further problems, try restarting the computer. Oh, that's funny. This version isn't completely stable, so I decided to put a version that was not too stable on my machine. So what they're talking about is these flags here, okay? So the little D in front says that's a directory. If there's no D in a dash, it means it's a file. If there's a little L there, it's a link. And then you have the, I guess the first thing is owner. I guess it's the owner and then the group and then all others. I think that's how they do these bits. Kind of fun. Yeah, and that's what they're talking about. Owner access bits, group access bits, and public or other access bits. Windows uses access control lists. Pretty complicated stuff. Let me see if I can illustrate that. Let's right mouse click, properties, security. So you've got these different groups and a user, that's me. So you can have groups, two users. There's two users here. The administrator and then the user. Okay? And then there's this group of authenticated users and system. And each of them have different authority, as you can see. And then you can even go further in advanced, and you can go down and talk about effective permissions for each of these groups or objects. So you could select a group or object and add more. It's got a lot more complicated, in other words. Okay, so every file has that. Imagine that the control information might be larger than most files exist. But anyway, Windows chose to use this, and it got more complex because they were having all kinds of issues with security, right? Got more complex with, this is XP, with Vista and that line. So Windows 7, Windows 10, they're all much more sophisticated in terms of capability of securing objects. Okay, I'm going to skip that. And that takes care of that. what I wanted to share with you is the first thing, I guess, is we shouldn't forget the CC confer question. Oh, I know why. I'm not quite ready for this. I said I wanted to share with you one more thought. So before we go there, let's share the one thought. Okay. So what I wanted to do is look at some things. First, most programs that show you data of a file, because files really are binary. I mean, they're stored using ones and zeros, right? Even if they're text files, they're going to be stored in ones and zeros. So you can look at those very simply in hexadecimal. And before I leave that, did you guys see The Martian with Matt Damon? Wasn't that a great use? I was so thrilled when he talked about the ASCII code. Yes. Yes, and it was really cool. Yes, that's right, 16 degrees or something. 360 divided by 16, something like that. 23.5 degrees, yeah, thanks. Yeah, that's pretty good. Very clever. And it brought something, you know, to light of how you could use this to communicate. At any rate, I was explaining that. And then I talked about my definition of file types. Textual, human readable, binary, non-human readable, programs, data generated by specific programs, Word, Excel, PowerPoint, pictures, compressed data, 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 databases, whatever. Okay. Programs, typically when they open a file, buffers are created by the OS and they're attached to the process. Okay, a file handle is usually created either a number or an object reference. Some OSs will prefetch a number of blocks of the file and place it in the buffer. The file access table is in memory, tracks the attributes. Okay. We'll talk about the file access table in a bit. Okay, the buffer. It's the OS stack associated with the program. Remember when we kind of divvied up program parts, when we looked at the parts of a program logically, we saw there was code, then the data segments, data area, right? And then the system area. Remember that? Those three components. And the system area contained the save registers and stuff like that from the process. Well, it also can contain buffers for files that are currently open. And this is describing what a buffer might look like. Okay. It puts this physical record as a buffer, and then inside your program might read records. Those are logical records. So it might do one physical I/O to bring in 3 logical records, and in your program you're reading those records. So what the operating system does when it says, you say read, in the system area it's got this buffer, and all it has to do when you ask for a read is to copy where it's currently in the buffer and copy that into your data storage area that you created your record structure in, and now you can read. So it doesn't need to perform a physical I/O. So it does perform an interrupt, right? We talked about that. But the operating system doesn't have to do a physical I/O. It just does a logical copy from the next logical record in your physical buffer. And most systems double buffer. They'll read two buffers. And the two buffers are two physical blocks of data. And those physical blocks, typically by your program, are logically separated. Let me see if I can show you more on that. No, it would take too long to do that. But is this clear, this concept? Okay, thank you. Okay, now we're going to look at how you could organize those. Now we're talking logically now, not physically on disk, logically. Sequential, one record at a time, and that's called sequential access method, or queued sequential access method, or virtual storage access method. Those are typically sequential. These same. I got these right from mainframe. These are mainframe terminology. Index sequential. It has two files. One is the data, the other is the pointer to the data. And that's called an ISAM, Index Sequential Access Method, ISAM file. Now, some mainframe ISAM files are three levels. They have three files, not two. What they have is they have the index file, the data file, and the extents. The extents are things that don't fit. As you're adding to records to the data file, they don't fit in there. They go to an extent or an overflow file. And then on these types of files, you have to periodically offload them on another, backup or some other device, and then reload it back and make your data file larger to support more inserts. Okay, so this index sequential file really had three files. I only mentioned two of them. Okay, so you could have data, right? 1 Dave's, 2 Art's, 3 Bob, and the index would be Art's in 2, Bob's in 3, and Dave's in 1. Okay? That would be organized alphabetically by key, your index file. Any questions on index sequential access method? Okay. The next one's a little harder to think of. Direct access requires a hashing algorithm, and it's basic direct access method. That's what DDAM stands for. Basic direct access method. And the idea is it would have a logical block like this. And it would have the pointers to the data, or it would have the data. So it depends on how this structure is created. On the mainframe, the way direct access was implemented was it would take a whole contiguous block. Okay, when you would allocate a direct access, it would allocate a whole contiguous block and basically have empty spots in there. Okay, because your records typically were fixed size. So the issue, though, on this direct access, and it's true in any direct access scheme, whether it's on the mainframe or somewhere else, you need a synonym chain concept. And the reason is typically the hashing algorithm is pretty good about spreading your key values that you're hashing to a specific unique location. but you'll get hits. Like, for example, art is hashing to 4 in this case, and Bobach is hashing to 4. So we would have a problem. But if it did occur like this, it would then look in the synonym chain and look up Bobach and say, oh, it's really at 5. So over time, if you have lots of inserts in this system, it's going to build up a big synonym chain and it won't be as efficient. But this is really efficient. The concept is hash, get it. Hash, get it. Okay? That's the concept. And that's what I'm explaining here. It's possible that 2 keys or names hash to the same number or location, and you need a synonym chain for the collisions. Knowing that, let's go to our CC confer question. What did Art say the 4-letter acronym is for IBM Mainframe's Direct Access File Organization, which requires a hashing algorithm? What is that? Right, you got it. It's BDIN. It doesn't matter case or not, uppercase or lowercase, doesn't matter. All right, you guys will do fine, I'm sure. Did anybody try it? And it worked, right? Okay, good. Good. Okay. Okay, the next thing I wanted to share with you is when we talk about how things get allocated and what where things are located. I mentioned on chapter 10, I believe, that there's a geometry that's taking place, and you have a platter, right? Which platter or surface you're on, either 0 or 1, right? And what track you're on, and what sector you're on in that location. Do you remember that from Tuesday? Okay. I don't know why I put the buffer here, but I put a buffer here. My definition of a buffer is a mechanism that provides synchronization for asynchronous actions or devices. It improves overall performance of the system. This really should have been, I don't know why it's here. It should have been with this discussion right here. Because if you think about it, I/O is slow. CPU accessing memory is way, way faster than disk reads or writes. Therefore, the buffer really is a mechanism that provides synchronization for asynchronous actions in devices. So you would do it on slow I/O would be put into the buffer in the system area of the program's memory, typically on disk, in virtual storage. It would put that block in, and then you would then feed it at real CPU speeds time each of the logical records, and that would go really fast. So a lot of systems block data records for this reason. And you used to be able to specify blocking. I don't see that much in the Windows operating system, providing blocks. If you write programs, you would typically block. I would block things. I was going to try and explain that to you. Let's see. What time is it? Oh, we have time. Let me do it this way. Let me do it this way. I was going to try and show you the idea of blocking logical. If you were writing your own programs. I don't want Internet Explorer. Sorry, I wanted Windows Explorer. And I'm going to go to tools. Done. Pretty sure it's done. I'm going to send to this program that I use. I still give credit to Colleen Emrys. Okay, 1995. She wrote a simple program, and I took her program and made it more fancy. But I want to make sure that whenever you look at the code, that the original programmer should see the big X code. And I converted it to C++.NET in 2012. But it's gone through a lot of revisions. But one of them was the buffer. What we did was we read and write in the buffer, and then from the buffer, read the data. And then you fill the buffer. So that's the concept of this, is to use buffers and read and write logical stuff from the buffer. Okay. What was the other thing I was going to do with you? Shoot. Got relayed. Oh, hexdump. Okay, I've modified it quite a bit. So, for instance, you can send any file. Let me pick a file. Oh, here's a Word document. So I have mine set up. I wrote this program hexdump. Right? Hexdump.win, so that it can take a file coming into it at the command line and open it. And then all you need to do is use this concept of send to. Have you guys used this before? Send to? It's a great feature. I'll show you that. But let me run the program. And you see right now it's loading it. And it's taking quite a while. I used to was it on this one I tried to use multiple threads? No, I didn't do multi-threading on this because multi-threading in .NET doesn't really work well when you're writing your programs. At least not on my processor. So anyway, it's gonna work a while because it's reading this document. It's taking time to do it. But we don't have to read the whole thing. That's why I have this cancel. And it shows you what it's got so far. So this is what a hex dump would look like. So at this location, and it goes for 16 bytes. So this is the 16 characters if you were looking at it from a human perspective. Otherwise, it's all binary. There's a whole bunch of binary zeros in this Word document. So if you look at it, and then they've got all, this is complex data structure because they've got all kinds of probably pointers and data information. And I don't know if we'll ever really see what's stored in this. And I cut it off too soon. It's a big file. It's 4.5 megabytes. That could take a while to process. Okay, well that's why. Let me close this one. Let me think a second. Yeah, I wanted to share with you how to set up that. So you would go to any Windows guy, you click up here, and you type shell : send to, no space. Okay, and that takes you to that location, which is your username, app data, roaming, Microsoft Windows, send to area. And you would put a shortcut. And like I have Notepad, and then I've got Notepad++, and I've got my hex dump. And so you would let me just show you the shortcut. So you would just set up the shortcut. I happen to have mine in this my tool C drive, so I could find it quickly. And that's all you really need to do. And then Windows will put this in the command line, and the file that you're trying to send to it would be in the command line with it. Okay? So it would be very much like this concept. Let me quit this to directory. It would be something like this: hex dump _Linn, passing a file like, let's do a small file, hex dump zip, the zip file. It's only 21 bytes, 21K bytes. So it would be just like doing this in the command line. And there it is. There's the program. And it loaded pretty quick for 21,000 bytes. But typical, this is what a zip looks like. It usually starts with PK. And if you researched that, there was a program, oh man, and I can't remember what it was years ago in DOS. PKZ, and I can't remember the author, but that became the standard for compressing files, and the guy really wrote a lot. He did a great job. Anyway, this is what a compressed file would look like. So I'm going to close this up. Now the other one that I gave you guys is the .NET one, hexdump.net. And if you look at the path, my path variable, somewhere in here I have that .NET, my tools, C:\/ my tools. Somewhere. Let's see it now. I stuck Python on front because I was having problems. I don't see my tools in here. Huh. Yeah, I don't see it in there. I should put it in because it should be able to find that program no matter where I am in the command line. It should find that by being in this path. But I don't see it right now. Okay. Now you guys know how to set up the path in Windows, right? Well, anyway, I'll show you the program. We'll do the same thing. We'll do this .NET. So Windows underscore net, and then we'll do the hex dump too. Yeah. And we'll pipe it because it's going to come out on this standard out. So we'll pipe it to more, and you'll see it didn't work because it's not called Windows net. It's called hex dump. That's funny. See that? Now you kind of know why people got frustrated with DOS, the command line. You have to really know what you're doing. You can't be a non-user user. So anyway, you see it's the exact same information, exact same stuff. Because I'm using the same underlying program from my Windows side. I'm calling this program. Okay, so that's there. So I showed you that. I showed you path and how to set the path in Windows. Okay, you would do something like this. Oh, sorry. Properties. I think it might be properties. Advanced system settings. That's the guy you want. And this guy here is the environment variables. And there's the user Linn, but you really want the path of the system. So you would come down here, hit the path, edit it, and add whatever you want to the path. So if you wanted to find a program that you wrote, you would add it to the path, and that's what I would do here. And there it is. I did find it. It's C, my tool. So it's right there. I did add the path. So I could run that program no matter where I was. And then you would say OK. And then you would say OK here. And that's how you could set a program up so that you could find it and run it in Windows. Any questions? Well, I don't know, was that helpful? Yeah, there's just tons you can do. Okay, I wanted to share one more thing. I got a on the internet. I'll put this link. I didn't put it on Canvas, but that's the link I'm at. And it does a nice job of explaining how floppy disks are set up, and it's fun to look at. And the sector size is 512, a half K. So remember, you could have so many sectors per track and so many tracks per drive. That's what this is. And I've had all of them. I had the 360 floppy drive. I've had the 1.2 meg floppy drive devices. And then, of course, the 3.5-inch floppy drives, which I still have. I was going to attach it to this machine and show you some stuff, but I couldn't get that to work the way I wanted, so I didn't do it. And then the floppy disk and logical structures to take a look at. It's pretty cool stuff. Okay. So 144, take a look at that. It just explains how it works. And you can look at all formats or the density of stuff. And it's nice. Okay, well that's something that you could do on your own for fun. Let me go back to the agenda. I think we're pretty much wrapping up for tonight. I don't really have much more for you guys. I talked about that stuff. I talked about direct access. I talked about index sequential, buffering, and I talked about hex dump and how to read a file, but what I didn't do was show you what's on as examples. So let's just finish with that. It's on Canvas here. Somewhere. Oh yeah, it's this file. Oh, and here's the hex dump program for you guys. That has both programs. So if you were going to look at a text file, it would look something like this. Dump. You can't see it like this because it's wrapping here. And that would be a binary file. I just took a little bit of a database file and dumped it, or I wrote a file or something to show binary. Okay, that doesn't really show you very well. Let me take a text file. Crack X, I don't know what that is, but let's send it to hex dump. Oh, it's a simple file. It looks like it's a phone number. Yeah, it's some kind of a phone number. But this is a text file, and how you know it's text, not just by the text name, but it has these two characters in it. ODOA is carriage return line feed. Carriage return is an OD, and line feed is an OA. In a Unix machine, you would see OAs, line feeds. They don't like carriage returns in Unix. If you ever look at a Unix file in DOS, you'll see it kind of run all over the place because they don't believe in carriage return. But Windows does. Okay. Questions? That's correct. Yeah, that's correct. If we were to look at this file, and I'll dump this file for you on hex dump, but right here, what the Notepad program does is it reads a line up until the carriage return line feed and displays it. But every time I do this, now watch, I'm going to do enter, I just put in a carriage return line feed. All right, I'm going to take it out. And so enter is not one character, but it's two characters. It's carriage return line feed. That's what, every time you hit enter, that's what goes to Windows. And inside Notepad, it knows that and captures it and says, oh, that's carriage return line feed. Well, it might, Mega, but if you look at, like we looked at Word doc, you can't view it as a text file because it only has the only binary data, typically text files. They don't display it, number one. Notepad typically doesn't display it, but maybe I'm wrong on that. Let me prove myself wrong. Let me open something with Notepad. And I'm sure I'm wrong because I remember seeing this. It's opening up that zip file, my backup. It's pretty big. Probably a bad choice. Yeah, it's a bad choice. Let me kill this thing. Now it's reading it. That's what's taking so long. Notepad. Oh, I didn't see Notepad running yet, which means it's a process. It's got to be running, not, yeah, there it is. Okay, I got rid of it. Let me pick another one. Smarter. See, what do I want to do? I want to do I want to do something binary. And not too big. These look like log files or something. No, let's go back up. Let's pick executor. Oh, it's another program I wrote in VB. This guy, 41K, it's not very big. So we'll send it to Notepad. And that's what I would expect in a binary file. You can't really read it. And there might be carriage return line feeds in here, but you wouldn't see them because they're non-printable characters. Any ASCII character from 0 to 31 is a non-printable character. This other stuff is high level. It's both regular, like S data. That's valid, but this special A is a higher character in the ASCII code. And remember, we're also in Unicode, so there's a bunch of stuff here, right? And this is a program. This is my executor program I wrote, which executes command lines. I tried to write a little command line processor, and that's what this guy was. For a company I was working at. It just made things easier to computerize logging on to a Unix box, doing file transfer protocol. And anyway, that's what Executor did. It did those commands. But that's what it looks like. Did that answer your question, Megan? Okay, good. Alright. But typically, you could tell, let me look at this log, open or send to Notepad. Let's see what this log is. Yeah, this is the log of the execution. I'm executing Notepad, and I'm opening this test file and waiting 5 seconds. And then I type, this is good, 1, and then I save it, and then I close the program, and then I'm logging what's going on at each of these scripts. So I display the script, and then I'm logging what happens during the script. When I turn debugging on in the program, I can see what's happening. And this is a text file. Okay. Let's see. I think I got everything for you guys that I wanted to talk about, and a few extra things. Well, I want you guys to have a great, unless you have a question, I want you to have a great weekend. And you know what's due. I went over that. I'm going to wait on this part till Tuesday when we talk about organization a little bit more. I know it would have been in tonight, but we're okay. Let me think. I think that's it. I'm going to turn off desktop sharing. Thank you all. You guys really are good. You're good participants. And I really appreciate that. Have a great evening.